This is the second example problem from section D, dimension. This one's C30, and we want to find the nullity, which is the dimension of the null space of this matrix. So nullity is just a word that means dimension of the null space. So first thing we got to do is find the null space of A. There's lots of ways to do that, but my favorite way is to use the extended echelon form by expanding this out and then using FS and BNS. So that's the way I'm going to do it. So first thing we want to do is add on and make an augmented matrix out of this by adding in the identity matrix at the end. So this augmented matrix now, I'm going to put that through the RF process. So we're going to end up with the extended echelon form of A. And that's going to be 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 1, negative 3, negative 2, 0, 1, negative 1, negative 2, 0. And then there's a bunch of other stuff, but I don't really need that because all I need in order to find the null set of A is the null set of C. And here's vector C, or matrix C, right here. So having C means I don't really need the rest of it. So it extends down here and over here, but I'm just going to block off that portion of it. There's the 0 vector, which frames the fact that I've got C. Okay, now I need the null set of C. And we can see here that the null set of C is easiest to find by using the basis of the null set. And so in essence, what I want are the two free columns, and I'm going to build those into the null set of C. It isn't the first variable, second, or third. It's really the fourth and the fifth. And those are going to be defined by these two columns. So the null set of C, which is what I'm after, is going to be, let's flip the signs on these, so it's negative 1, 3, 2, 1, 0. So that would be for the fourth variable, the first free variable. And then the fifth one is going to be negative 1, 1, 2, 0, 1. So there it is. That's the basis of the null set applied to matrix C, and that being the null set of C, and this guy coming from the four subsets from A, that also makes this the null set for A. So that's by the FS, and we found it through the BNS, the basis of the null space. And now we want the nullity, which is just the dimension, and clearly this contains two vectors. So the dimension of the null set of A is equal to 2. Now we could have found that a little bit easier if we had just gone ahead and found the reduced row echelon form of A. We could have said, hey, A contains 5 variables, right? So n equals 5. And we can see that we've got 3 pivot columns. R equals 3. And of course the difference between those is 2, and that's also the dimension. So just going straight to the reduced row echelon form would have done it, but I wanted to kind of see what the dimension was based on before we identified it. But that's not necessary. If you just want the dimension, you can go straight there with the reduced row echelon form.